Number 32. Which of the following is one of the 4/4 roots of the complex number 81i? Answers are in standard form and have been rounded to the nearest hundredth. So to do this, we're going to use something called, I don't actually know how to say this, de Moivre's theorem. And it's for taking complex numbers to powers. So if you have the complex number r cosine theta plus I sine theta, and you raise it to an exponent of, say, n, then the result of that is r to the n multiplied by cosine of n theta, not 2 theta, cosine of n theta plus I sine of n theta. I wrote a 2 again. I sine of n theta. So you raise the distance, you raise r to the nth power, and then you multiply all of your angles by n. So if we have this complex number, 81i, well, if you think about it, 81i on the coordinate plane, on the complex plane, this is the real axis, this is the imaginary axis. 81i is going to be somewhere on the imaginary axis, on the positive imaginary axis. And so if we measure the positive real axis, or what would normally be the positive x-axis, as 0 degrees, then this would be at a 90-degree angle. And also it's 81 from the origin, so our r is 81. The r is the distance from the complex number to the origin, and the theta is the angle from the positive real axis to the number. So this would be 81 times cosine of 90 degrees plus I sine of 90 degrees. Then if we're trying to take the fourth root of this, raising this all to the 1/4 power, let's see, 81 to the 1/4, the fourth root of 81 is just 3. And then let's see, cosine of 90, so instead of cosine of 90, it would be cosine of 90 times 1/4, which is cosine of 22.5, and then plus I sine of 22.5. So this is one of our fourth roots. So let's see, it says which one of these is a fourth root of the complex number. So we can just evaluate this and go ahead and see if this is one of the fourth roots. So 3 times the cosine of 22.5 plus I times the sine of 22.5. Let's see, we get 2.77 plus 1.15i. So let's see if that's an answer. 2.77. No, we don't have that as one of our answers, but we can figure something else out. So when you have roots of complex numbers, it turns out that they're all at equal angle distances away from each other. So what I mean by that is if you have 360 degrees total in a circle, and let's say our root, this one that we found right here, is one of them, and let's say it is right here, then the other roots are going to be distributed around the coordinate plane at the same distance from the origin and equally dispersed. So if you have 360 degrees and 4 roots to place equally distant apart, then they're all going to be 90 degrees apart. So there might be one right here. This is a 90-degree difference. There might be one right here. This is a 90-degree difference, and there might be one right here. Or I say there might be one. There is one right here. It might be one of the answer choices, but there is a root right there. And so then the way that we find what those are actually equal to is by just plugging in the different angle measures. So this root is the one that we just found. It's 3 away, and it has an angle of around 22.5. So to find this one, we can test this one out, is we just add 90 degrees. So if we go back to our calculator, we can just add 90 degrees to all of our angles. So plus 90 on both of these. So let's see if this is an option. Negative 1.15 plus 2.77i. Negative 1.15. Nope, doesn't look like that's an option. So we got to find the next one. So to find this answer, or to find this root right here, we just add another 90 degrees. So plus 90 plus 90. So negative 2.77 minus 1.15i. I think I remember seeing this one. Negative 2.77 minus 1.15i. Let's just double check that. Yes, so this matches up with answer choice E. And then if we wanted to find the last root, all we would have to do is just add another 90 and then repeat the process. So if we wanted to find the other one, we would just, instead of doing cosine of 22.5, we would do cosine of 22.5 plus 270 degrees. The other thing you can do for this problem is you can use your calculator. I know the TI Inspire can do this. I don't know which other calculators can do this. But if you go to Menu, 3, and then all the way down at the bottom, or almost all the way down at the bottom, there's Comp C for complex, and then Solve. I didn't actually input it. So Menu, 3, C, Solve, and you can say 81i equals x to the fourth. And so then when you solve for x, it'll tell you one of the four fourth roots of 81i. And so just looking at here, see this first one is the first root that we found. And then, so let's see which one is the one that we found. The negative 2.77 minus 1.15. So yeah, that's the one all the way at the end. So if you're a little bit pressed for time, you can always use this function. I wouldn't rely on this because sometimes the questions that they ask require you to know how to use this theorem, and it will save you a lot of time. But for certain questions, you can just use this. So here, negative 2.77 minus 1.15i, and yes, that is answer choice E. Alright, so if you have any questions from other tests, make sure to leave a comment, and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.